Thank you for your joining to the lecture. The subject of this lecture is the decision support systems and optimum planning policies of constrained resources in drought management. Yes, drought is a natural disaster that usually progresses slowly and its effects are long-term. For this reason, it's essential to take necessary precautions before the drought occurs. Drought management and planning process should be carried out within the framework of risk management. Thus, it's aimed to minimize the long-term effects of drought. Here, we can see the views from different parts, different regions. On the other hand, as stated by Wilhite, when the drought crisis occurs, it is seen that the precautions taken suddenly are not very effective, and even some wrong decisions can be taken. Therefore, against drought, it's essential to create plans based on risk management, not on crisis management, both at the regional level and through the country. Within the scope of drought management, the inability to distribute water in irrigation networks in a measured manner and the deficiencies in the operation, maintenance and repair of the networks can reduce the effectiveness of drought planning. Therefore, optimum operation policies of water resources and irrigation systems are vital in drought management. As in the example of GAP project, in the unplanned and excessive use of water in wet conditions before the arid conditions have caused salinization and barrenness in the large agricultural lands in the region. This situation shows that water resources should be used on the basis of drought risk under all circumstances. In other words, the optimal use of constrained water resources in spatiotemporal dimension under current conditions is essential. In this process, preparing models that will provide the highest benefit from the unit amount of constrained water and soil resources and application of them, determining the plant pattern in accordance with the existing water resource capacity, soil characteristics, and the infrastructure of the irrigation system. In this planning process, it is of great importance to take precautions to support the farmers. In Turkey, risk management and drought planning have been understood and tried to be implemented. For this purpose, agricultural drought management strategy and action plan of Turkey has been prepared. While this plan is based on risk management, the understanding of crisis management also shows its effects. One of the main objectives of the agricultural drought management strategy is expressed as follows. With sustainable agricultural water use planning, it's to ensure that all necessary precautions are taken for the future in periods when there is no drought and that the effects of drought are capped at a minimum by applying an effective management program in times of crisis. The activities envisaged to be carried out in the management process of agricultural drought are determining the agricultural basins and taking into account the water resource potential there. And the second one, determining the most suitable areas for each crop type and thus reducing the use of water in agriculture. In this process, the development of multi-objective planning models provide great benefit. In an investigation carried out, a multi-objective planning model was developed on the Menemen irrigation system in the Lower Geddes Basin. This investigation was carried out by KILIÇ and Anaç. Objective functions of the model are maximization of benefit from agricultural production, maximization of irrigated area, and minimization of water loss at network level. This means maximization of irrigation efficiency. So, multi-objective planning models are more effective in solving such kind of problems. Also, there are constraint functions. They are available water resource capacity, water carrying capacity of the canals, irrigation networks, length of irrigation time allocated for each distribution zone, the amount of water that the canals can receive during the system rotation period, irrigation water requirements of crops, sizes of land suitable for growing different crops, and the non-negativity constraints. They are the constraint functions of the multi-objective planning model. The following results were obtained by applying the model to the research area. First, the expected income from agricultural production has increased by 20.63% compared to the current situation. In addition, the total irrigation water requirement of the plant pattern defined according to the model decreased by 29.26% compared to the current situation. In other words, the selection of the optimum plant pattern for the research area resulted in significant water saving. This is important finding. In this process, the expected water loss at the network level has decreased by 29.90% compared to the existing situation. These results shows the importance of the multi-objective planning models. Another activity envisaged to be carried out within the framework of the action plan to manage agricultural drought is to ensure the effective use of groundwater for agricultural purposes. Especially in periods when water shortage is intense, farmers use groundwater and drainage water, if possible also, as alternative source when they cannot make use of network water sufficiently. So it's of great importance to develop models for optimum use of resource for different water constraint levels, taking into account the capacity of these resources, the cost of use, and the irrigation water requirements of the crops. For this purpose, an optimization model was developed by KILIÇ, considering the above-mentioned components. In the study carried out on the Lower Gediz Basin irrigation system, network water, which means canal water, groundwater, and drainage water were evaluated as alternative resources. Thus, it is aimed to obtain the highest income from agricultural production by providing the optimum combination of alternative resources at different water constraint levels. Another activity to be carried out within the framework of the action plan to manage agricultural drought is to provide measured water distribution at the network level. Here we can see the limnimeters, limnographs in irrigation networks, in open canal irrigation networks. More than 80% of irrigation systems in our country consists of open canal networks. In Turkey, we have this canal system. It does not seem possible to transform this structure into a fully pressurized system in a short time, both in terms of time and in terms of economy. On the other hand, agricultural production and use of irrigation water continues without stopping. Thank you for your attention to this lecture.